Yes, Zen, where were you? Your exams are going on, no? So how was your exam, Zen? Okay, then share the question paper with me. Your question paper, no? Please share it with me on WhatsApp. I think Kulsum is having network issues. Let's start the class. So who all have joined? Sara, Zain, Hiba, Hamza, Fatima. Akifa had her exam and Kulsum is joining. Okay, class. So we had started with spherical refracting surfaces and those two derivations, those two lengthy derivations, we had completed it in the last class only. So how do we divide it? From denser to rarer and from rarer to denser. This is how we divide the classification of this. Now see class, both the formulas that we had obtained from the rarer to the denser medium. The formula of this for the spherical refracting surfaces included n1 by minus u plus n2 by v is equal to n2 minus n1 by capital R. Zen, I think you had not gone through any recording or any part of this, no? So do take the video lectures from me. Text me on WhatsApp and take the video recordings, because this part of ray optics, some of the portion has been covered, which is very important. I think total internal reflection was also missed by you and all these parts. Fine, so just have the recording. I'll share the whole entire playlist with you, but do remind me once. Then for the rarer, denser to rarer, opposite one, the formula had a difference. This was a very long derivation we had seen, n2 by minus u plus n1 by v is equal to n1 minus n2 by r. Instead of n2 minus n1 by r, we have it as n1 by n2, n1 minus n2 by r. So this completed the topic, but we have not completed any, we didn't do any numerical. Let's do a question on this. Okay, so this question says what? It says an object is at a distance of 20 centimeter from a spherically refracting surface. Of radius of curvature 10 centimeter, calculate image distance, refractive index of glass is given as 1.5. See, refractive index of glass is given, it means refractive index of the one of the medium is given. If second medium is not provided to you, that means this is which medium? Definitely air is there. See class, I'll tell you, just try it once by yourself, then we'll discuss it, because one numerical only we'll do from this topic. Rest of the numericals are the same. If this is a part of a glass, object is at a distance of 20 centimeter. This is the position of object. This is 20 centimeters. From the pole of the spherically refracting surface, this is 20 centimeters. Radius of curvature is given as 10 centimeter. Figure is given in the question. You can note down the figure also. This is 10 centimeters. It says calculate image distance. This is 1.5, and this, since this is here, this is 1. So n1 will be 1, n2 is 1.5. See class, n1 is 1, n2 is given to you what? 1.5. Object distance, object is kept in front of the refracting surface. So this will become minus 20 centimeter. Whereas the radius of curvature is behind the refracting surface. So radius of curvature will become plus 10 centimeters. Use the equation that we had seen, we had derived in the last class. This equation was what? N1 by minus u plus n2 by v is equal to N2 minus N1 divided by R. See, put in everything. See what is the value of V you're obtaining. It's a formula-based question only. Send me your answers in the chat box, then we'll discuss it. Try to answer by yourself. Yes, anybody got any answer? Let's keep it in the formula. See, N1 by NU, N1, N1 is 1 minus U. So minus U is already there in the formula. Now you are getting U again as minus. That is minus 20 centimeters. So minus into minus 20. Minus 1 by minus into minus 20 plus N2 is 1.5 divided by V. Image distance is not given to us. Then N2 minus N1. This becomes 1.5 minus 1 divided by the radius of curvature. Radius of curvature is given as 10. See what is left. 1 by 20 plus 1.5 by V is equal to 0.5 by 10. If you write 0.5 by 10, just a second, class. Thirty centimeter. No, not 30 centimeters. Check your calculations again. This is 1 by 20 plus 1.5 by V. This is also 1 by 20. So 1.5 by V will be equal to what? 1 by 20 minus 1 by 20. So reciprocated, this becomes This is 0. See, this part will, because both of it will get cancelled. So this becomes v divided by 1.5, 1 by 0. This will get reversed, and 1 by 0 is infinity. So even 1.5 multiplied by infinity will give you infinity. So image distance will come infinity. All right, note down the solution. C class. Lens maker formula. Before we begin with lens maker formula, let us understand lens. When we had the spherical glass part, for example, we had the spherical glass part. Now, if you cut that part, one of the part that you obtain, if you polish it, you get what? You obtain a mirror. Now, if you take this part and do not polish it, then you get refracting surfaces, the way we had read and understood the refracting surfaces in the last class. But if you take these two refracting surfaces, suppose I cut it from here and I cut it from this end as well, and now I join both of them. So now the structure that you will obtain, this is known as a lens. A combination of two spherical surfaces, this is known as lens. Fine. Same spherical part is there. If you cut one part and you silver it, you polish it, you obtain a mirror. Mirror is done, mirror formula, everything reflection that we study. After is, if you just have that spherical part and you do not polish it, then it acts as a normal spherical surface where refraction occurs from rarer to denser and denser to rarer, what we had seen in the last class. If two spherical surfaces are combined in different orientation, those are known as lens. For example, one side I have taken, one more part I take. So this is known as biconvex. Two convex portion have been connected like this. This was one of the part of the sphere, this was another part of the sphere. Now I have combined it. This type of lens will be maximum used by us. This is biconvex lens, or this is also known as double convex. This is known as double convex lens. Now, if I take this curved portion, but the other part, the remaining part, I'm joining it with the plane mirror. This is the curved part, this I'm joining it with the plane mirror. Like this. This is known as plano convex. Plano convex part. This is straight, this is curved, like this. Both were curved, the biconvex. One straight, one curved, plano concave. What if I take these two spherical parts and instead of joining like this, I join the other part like this? Just the difference in orientation. This was one of it, which was connected like this. Other part I am connecting it like this. This is known as concavo convex lens. Fine. So out of these, most widely used is convex lens. We will be using the general term convex lens only. And you have biconvex lens. One more thing also. If I take these two surfaces, instead of combining like this, I can combine it like this. I had combined the two spherical surfaces like this. Now I combine the two spherical surfaces like this. So see, one part will be this, other part will be this. So this type of lens is known as biconcave. Biconcave lens you can say, or even you can say this is also known as double concave. One more thing, if I take this part, I had taken this part, curved part, and I had combined it with the plane part, plane mirror. So this that was obtained, we called it as plano convex. If I combine it like this, means this part is there and this is the plane part. So this is known as plano concave. Plano concave lens. Understood? Now the way we had few terms like pole of the mirror, we had optical center of curvature, we had radius of curvature was there. Similarly, we'll be having one more very important thing that is known as the optical center. See, we always consider these as the thin lenses. These are the thin lens. Thin lens means aperture is very small. The aperture of the lens is very small. It means the distance between this point and this point is very less. We are drawing it farther away, but actual separation between them it is very less. All right. Now, optical center is what? Optical center is the exact center that is present in the lens. So this will become the optical center for convex lens. This is optical center. So rays do pass through this point. For example, this is your point. From here, the lens do pass. Let's say this is P1 pole is this P1 and this pole is P2. So from here and this is O, that is your optical center. Here this is also O, this is P1, this becomes P2. This is known as the optical center for it. And again, a ray of light can easily pass through this optical center. Now, this type of convex lens that we have, this actually converges the images. Rays of light will be parallel and it converges the images. So we call convex lens as converging lens as well. Whereas diverging lens or diverging images is produced by the concave lens. So this one is known as the diverging lens. One more important term, that is focus. Focus was present in case of the mirror, and the mirror formula also we did. Focus will be there of the image. See, in focus you have, for example, this is your biconvex lens. This is the optical center. Now, this is one spherical refracting surface. This is also one spherical refracting surface. If both the spherical refracting surfaces are combined, it means this will also have its focus somewhere. This part will also have its focus somewhere. Both are joined together, no? So it means both of these parts will be having one of their focus. So there are two foci present in lens. One will be here. This will be another. So let's say rays are coming. Rays have come and they get converged. Parallel rays have come, they get converged at this point. This is the image. Object must be at infinity. Now this is known as what? This principle is known as second principle focus. This is called as the second principle focus. And this one is known as the first principle focus. Because two refracting surfaces have been combined together. So both will have its own properties. No, both will have, because both are the part of the same sphere. So each will be having the radius of curvature. Each will be having its own focus. That's why. Even if rays are parallel from this point, like this, then they will converge at this focus. The image will be formed at this focus. So this is known as what? This is known as the first principle focus. This is known as the first principle focus. So you can easily note the fact that in case of lens, there are two principal foci. One is the first, second is other one. Now, converging lens does what? Converging lens simply converges the light rays that are coming at a particular point. Whereas the diverging lens we have not seen. Let's see it. This is the optical center. Rays of light are coming. So for the concave, since see, this refracting surface has been shifted now. Earlier, this refracting surface was like this, so its principle of focus was here. Now this is like this, so its principle for focus has shifted here. That's why F1 and F2 are exchanged now. Now this gets diverged. So how will you obtain the image? If all the light rays are getting diverged, how will you obtain the image? You will get a virtual image. You will produce this image backwards. At this point, you will obtain the image of it. All right, like this. Or even you can take the example, this is your lens. F2, F1, even if rays of light are coming from the other side, from this side, if these rays are coming, the rays gets diverged. Because the work of concave lens is to diverge the images. Now, if you produce the image, they appear to meet at a point, this becomes your image. So the way we had for the convex lenses, for the concave mirror, we used to obtain a real inverted image. Similarly, for convex lens, you will obtain those kinds of images and they will be real images. The way for convex mirror, you had virtual images that were found behind the mirror. Here, in case of concave lens, the images will be virtual. So most commonly, everything will be standardized by the convex lens. The way concave mirror was a prime concern, now convex lens will be. If I note down these points, then we'll start with the lens formula, how to go about the derivation of lens maker formula. Lens formula is different, lens maker formula is different. The way mirror formula is there, no, 1 by f is equal to 1 by v plus 1 by u. Similarly, one lens formula is also there, which also relates 1 by f is equal to 1 by v minus 1 by u. Lens maker formula is different. That involves your refractive index of the medium, all these different radius of curvatures are also involved. That we'll see. Lens formula, we'll do it in the next class.
Teacher, can you please scroll up? Yeah, here. Okay, teacher, you can scroll down. Thank you.
See, now we are going to do lens maker formula. As I've told, there's a difference between lens formula and lens maker formula. The way we have mirror formula, which connects focal length, object distance, and image distance in mirrors. Similarly, we have lens formula also. We'll be using in the derivation as well. Lens maker formula connects focal length of the lens, radius of curvature, both the radii that are present, and refractive indices, along with the object distance and image distance. We use object and image distance in the derivation itself. At the end, we just have the refractive index, focal length, and radius of curvature. This formula is known as lens maker formula. See, figure has been already drawn. This is a lens. All right. Okay, so in this lens, what do we have? See, object O1 is there. From this, rays have passed onto this surface and rays got refracted, and an immediate, this immediate intermediate image was formed. Intermediate image was formed. Fine. Then this intermediate image acted as an object for this refractive surface to occur. See, there are two refractive surfacing. So for two refracting surfaces, 2 times refraction will occur. In the final questions, you will see, you will be directly doing it, or in the even in the day diagrams, you will be directly doing it. But in reality, how do we solve this? we take both the surfaces, at one surface refraction occurs, then at this another surface refraction occurs. So similarly for the object 1, because of this surface I1 is formed. Now I1 is acting as an object for the next image, and final image that we get is this I. P1, P2 are the poles, C1, C2 are the radius of curvature, radial are the points of curvature, radii are R1 and R2. Fine. This is the rarer surface. This is denser. So we'll be using formula for refracting, spherically refracting surfaces for rarer to denser. Then we'll use it for denser to rarer. Understood what we are trying to do? Rarer surface is there, light has entered, it has got refracted. So it's denser, rarer to denser. Full formula directly we'll use. Let's even do it. Let's do this part first. See, for rarer to denser, if you talk about rarer to denser, from air the light rays are entering into the glass directly. So O1 is the object right now. And now the first image that has been formed because the rays had entered from rarer to denser, that was I1. I1 was the image that was formed. If you put it in the formula, you get N1 minus U plus N2 by V. Let's write it as V1. For the image distance of this, I think I had written V1 only, yes. This intermediate image distance is V1. So I'm writing V1. Actual image distance is V and object distance is U. So that's why minus U plus N2 by V plus V1. This is equal to N2 minus N1 divided by R. First equation that you will be needing. This is not as lengthy the way we had it on the last class on Tuesday. Those two derivations we did, that they were so long. This is just solved in 2 to 3 steps. First step is this only. Second step, from denser to rarer, where the second refraction has to occur. See, I1 now acts as the object. So object distance that you will take will be V1 only. And see, final image is I1. I1 is the image. Now, if we put in the formula for denser to rarer, this becomes N2 by minus U. So that becomes V1 because object distance is now I1 plus N1 by V. This is equal to N1 minus N2 divided by R2. This is the second equation. Just add both these equations. Add 1 and 2. Add these equations together. See what you'll obtain. First one was N1 minus U plus N2 by V1 is equal. You're adding, no? So in addition, the second side will also come. So that was, for the second equation, we had N2 by minus V1 plus N1 by, what was it? N1 by V. N1 by V. This was N1 by V. This will be equal to N2 minus N1 by R from the first equation plus N1 minus N2 by R from the second equation. Anything is there? Anything that is, yes, this is getting cancelled. N2 by V1 minus N2 by V1. So what are we left with? If you take N1 common, you are left with 1 by V minus 1 by U. This is equal to, take N2 minus N1 also common. You are left with, okay, one more thing class, not R. For the first one, this was R1. For the second will be R2 because now the radius will also get changed, not R1. If only we write one single R, then there's no point of having two foci or two radii. So that means this is what? This is R1. So that becomes R1 minus R1 by R2. Because N2 by N1, I have taken it common from here. Fine. Now see, this was the formula I was mentioning you about. This formula, this is known as Lens formula. We'll do derivation. The derivation of Lens formula is there in your syllabus. Lens formula completely we'll do. Lens formula is basically 1 by V minus 1 by U. This is your Lens formula. 1 by F is equal to 1 by V minus 1 by U. So if 1 by v minus 1 by u is occurring, I can write this as 1 by f. See what I have obtained. So this becomes n1 into 1 by f, which is equal to n2 minus n1, 1 by r1 minus 1 by r2. Clear? Whatever the right hand side was, I have not changed it. Left hand side, I have changed this. Okay, let's shift this n1 also here. So 1 by f will be equal to n2 minus n1 by n1, 1 by r1 minus 1 by r2. If we shift this, the denominator of this, if we write the denominator separately, 1 by f, if I write this as n2, n2 by n1 minus n1 by n1, this is 1 by r1 minus 1 by r2. So 1 by f, this gets cancelled. This is 1. This can be written as n21 minus 1. See, n2 by n1 can be written as n2 by n1 is written as n21. Refractive index of second with respect to the first one. What is left? 1 by r1 minus 1 by r2. This is your lens maker formula, and you have to consider it with proper sign conventions. This is known as this formula. This is known as the lens maker formula. This formula is known as lens maker formula. And consider sign convention. I have told you so many times, it's the case of only optical instruments where I'll specifically tell you not to consider sign conventions. Otherwise, you have to consider proper signs. Signs means sign convention. Fine, before we move on to the numerical, start writing it down. At whichever point you're not able to understand, the derivation is not tough. Two equations were there. Those two equations were simply added. But still, if you have any difficulties, let me know. I'll answer it.
Ma'am, do you measure the distance from the optical center or the poles?
Yes, yes. The way we had everything measured from the principal axis. Here also, everything is measured from the pole first. Actually, it is measured from the pole. But since I've told you, the aperture is so small. This aperture, we are drawing it broadly. But actually, in reality, this is from pole only. This is also from pole. This is also from pole. But whenever you will be drawing it, you will be refracting it like this. But actually, this is not happening. Two surfaces are there. From here, refraction will occur. From here, refraction will occur. But since the aperture is so small, that's why we ignore all these things. So that's why I've written it from the optical center. Otherwise, in reality, keep it in mind that this is from the principal axis only, a pole of the mirror on the principal axis. Okay.
Yes, ma'am.
See, this question is given. Here you have a concave lens. 1.5 is the refractive index of it. 10 centimeters is one of the radius of curvature. Second one is 20 centimeters. Fine. You have to calculate the focal length of this. So focal length will be calculated directly by this formula only that we have studied. See, what all things are given. N1 will be 1, N2 will be 1.5. This is what? This is the first center of curvature. It means radius of curvature. So since this is in front of the lens, this becomes minus 10 centimeter. This becomes plus 20 centimeters because this is behind the lens. So put it in the formula. 1 by f will be equal to 1.5 minus 1 because divided by 1 is 1.5 only. 1 by minus 10 minus 1 by 20. Solve it, see whatever you're getting, that will be the answer. Quickly write it down, one more formula, one more numerical will do. Answer, how much it's coming? Minus 0.075 centimeters. I do not remember the answer for this. Please, somebody else also cross check. What's the answer coming? I think answer was minus 40 by 3 or minus 13.3 centimeters. Maybe. Just check. Others also check whether it's minus 0.075 centimeters or not. Atif, you also just recalculate it once again. One last numerical. Okay, let me know. Just see your calculation. I think it should come out to be minus 40 by 3 as far as I remember the answer. But exact thing to calculation के बाद देखो क्या रहा है. Okay, this question.
The
कितना है?
answer is wrong. I calculated -3/40 by mistake.
Okay. Just check. Just check and let me know the answer so that I can write it. -40/3 no only. Sara is also getting. So -40/3 होगा फिर. Because I think what the answer was, what I remember, it was -40. Since I was not sure, that's why I was not writing. It minus 13.3 centimeter. I think -40/3 is this only. Just cross check. I think Sara is also getting it. So both of you. This question says that a convex lens of focal length, how much is the lens given? 0.2 meters, made up of glass, is immersed into a liquid, and the refractive index of the liquid, or what we know the liquid, that is water, is 1.33. Actually, this is 1.3 only in the question. And it says find the change in the focal length. So initial focal length, see, when the focal length is kept, this question says what? This question says that the glass is there, convex lens is there, this is air, this is the glass. Fine. Here the focal length is coming 0.2 meters. Now if this lens is dipped into water, medium will become what? Water. If you dip in and dip this convex lens into the water, then this becomes what? This becomes equal to the medium changes and it becomes the water. So that's why it's a new focal length will generate. So the difference in the focal length is asked to be calculated. See, 1/f is what? We'll start with lens maker formula. This is n2 by n1 minus 1, 1 by r1 minus 1 by r2. Now we do not know what is the 1 by r1 plus 1 by r2. Now we do not know why 1 by r1 plus 1 by r2. See, I'll tell you. Just at the end of when you will practice a lot of questions, automatically your hand will get set whether to write plus or minus. I'm writing minus. See, the main formula is this. Let's say radius of curvature here, this is R2, and radius of curvature here is R1. So it means R2 will become negative and this becomes positive. So if R2 is minus R2, what will be the formula? This becomes N2 by N1 minus 1, 1 by R1 plus 1 by R2. Now 1 by R2, 1 by R1, you do not know anything from here. Just you know the focal length and the refractive index. So at least calculate 1 by R1 plus 1 by R2 is what? So that in the new focal length, at least you will have this data. 1 by focal length is 1 by 1.0.2. N2 is 1.5 minus 1. 1 by R1 plus 1 by R2. This becomes 1.02. 1 by 0.2 into 0.5. This is equal to 1 by R1 plus 1 by R2. Now medium gets changed. Now the medium is water. Same lens is taken, but if the focal length, obviously focal length will get changed, the medium gets changed. So this time the surrounding is water. And this is the glass that is made up of 1.3. So now the new focal length will be what? 1.5 by 1.3 minus 1 by 1 by R1 plus 1 by R2. Radius of curvature will not change over here for this one. So radius of curvature sum, you can take it from the above equation that came out to be f, not 1, f prime I have taken. No? So this will become 1 by f prime. This is the new focus. This becomes 1.5 minus 1.3, 0.2 by 1.3 into 1 by R1 plus 1 by R2 is 0.5 into 0.2, 0.2, 0.8. 2 gets cancelled. F prime will become what? This becomes 1.3 into 0.5, no? So this becomes 0.75, no, 0.65. This becomes 0.65 centimeters. So initial, just check. Please keep on cross-checking. I just do all the calculations orally in the class. So change in focal length will be what? Final focal length minus initial focal length. This is 0.65 minus, what was the original focal length? 0.2. So this is your answer, 0.20. So you can write it as 0.4 centimeters. This is the final change in the focal length. This was only asked us to calculate the change in the focal length that has arisen. Fine. So note down this numerical as well. I'll stop here. Then we can proceed with the reflection test.
Ma'am, should we always take R2 in the left side and R1 in the right side?
Yes, R2, R1, R2, you have to fix for your own. Whatever is the radius of curvature towards the left side, that will be negative. So even if you change the variables meaning will not get changed. This will be the radius of curvature for this side and this will be the radius of curvature for this side. Even if you change the variables here, there won't be any difference. For you, what is R1? For the rest of the people, it will be R2. But if we have a specific value, let's say this is 5 centimeters. So for you, you will write R1 as minus 5 centimeters. Somebody who is, or other students, somebody who else has taken this as R2 will write this as minus 5. Ultimately, you'll have this as same. But remember to take this side as negative and this side as positive. Otherwise, the answer won't match. So variables, it's up to you. You can take R1, R2. Sometimes I also reverse it.
Okay, ma'am.
Just text done in the chat room once you have completed writing till here. Okay, I think only Sarah has completed. Others also just text me done once you've completed. Hamza, Hanifa, Atif, Zain, Fatima, Sarah all have completed. What about others? Is somebody left? Hiba done? Josefa done? Okay. Let's start with your test. Short test is there, 3 questions. I think you will be able to complete it in less than half an hour duration. Zen, are you there on the WhatsApp group? Okay, then after you've completed the paper, convert your images, click the picture of the images of your sheets and then convert it into a PDF and upload it on the WhatsApp. I'll take your paper from the group only and I'll check it and share the answer with you. Okay, Zen, but submit it soon as possible. And if you have completed the paper, then you can leave the meeting. Okay, Josefa have what? Josefa, Fatima. Josefa, you can also leave. I've received yours. And Fatima. Hanifa can also leave. Others, hurry up. Sarah can also. Sarah, you can also leave. I have received your paper also. Hamza and Hiba, what about you? Have you submitted it or not? Okay, okay. And what about you, Hiba? Have you also submitted or just let me know because I've not received? Okay, okay, Hiba. So I think Hiba is left. Hiba and Hamza are left only. Okay. Just text me once and let me know if you've submitted once you've submitted. Hamza.